Right. So this is what we call the parent's function. Y equals the absolute value of X, where we have, what letter does this look like? It looks like a V. So the corner of our V, this is what we call the vertex, okay? And when we have just the absolute value of X, our vertex is at the origin, and we have slopes of 1 and -1 to make our V, okay? Now, what's going to happen is this H right here is going to tell us whether we're going to move right or left a certain amount. And this K right here is going to tell us whether we move up or down a certain amount from the origin. Okay. Now, what did you notice about when we played with the numbers inside the absolute value, Henry?
It remained positive. It's absolutely.
So when we played with the numbers where H was. Okay, if it was X minus 2, which direction did it go?
Right.
If it was X plus 2, what direction did it go? Left.
Well, it's because the
Well, but you would like have to do whatever numbers you're plugging in, Henry. You would do this operation first and then do the absolute value. Okay, sorry.
you like so for this
It's like the opposite.
yeah.
Yeah. So like when I'm going to find the vertex of this guy right here, what direction is this vertex going to go from its original? DJ? Okay, so this is saying, hey, we're going left 2. And this is saying, hey, we're going down 3. So our vertex is -2, -3. Now, what about this? If X minus 1 is inside of our absolute value, what direction are we going? So when we are inside the absolute value, it's going to be backwards from what we want it to think. Because if I set X plus 2 equal to 0, I would get -2. Okay. It's just when we're inside, it's going to be backwards because of that, like setting it equal to 0 equation that we could do. Okay. So this X minus 1 means we're going which way? Right. This means we're going right 1. So, oh, but there's nothing over here. 0. Okay. So our vertex is at 1, 0, because this is like a +0 right here. Okay. What about this vertex right here? Do we go right or left any? No, so it stays at 0, but then it goes up 4. Okay, so 0, 4 would be our vertex. Okay, so these are actually really nice to graph because you know how to count slope. Yay, us. Okay, we basically need to graph a V with a piece that has positive slope and a piece that has negative slope to make our V. Okay, that's what we call a piecewise function. Really weird. You'll learn all about it in Algebra 2. Okay, so this is what you're going to do. You're first going to figure out where your vertex is. Okay, A changed the slope of the graph. Basically, if A is bigger than 1, your graph is going to stretch. It's going to be a skinnier V. But if A is between 0 and 1, you're going to have a less steep slope and it's going to get wider. It's going to shrink vertically. Okay. Now, what happens if there's a negative in front of A? It's going to go upside down. Okay, that's called a reflection. It's going to reflect. Okay,
What does A stand for?
A is the number in front of the absolute value. Start right here. Okay, H and K give us our vertex. A is going to give us our slope. Okay, so what we're going to do is we're going to take A and we're going to count our slope to the right. And then we're going to count our opposite slope to the left. That way we get that V. Okay, and A is going to help us out with this right here. Okay,
Why was the first one A?
then it's going to be a 1. If we don't actually see a number, then we know that that number is 1.
0 is a number.
Well, if we're talking, since A is being multiplied to the absolute value, since A is being multiplied, if we don't see a number, 1 is being multiplied. If it's something that's adding or subtracting, that's when there's the invisible 0. So let's look at this graph for number 5 right here. Okay, raise your hand if you can tell me what the vertex is. Gabe. Okay, Gabe says 0, -2. Drew, how did he get that? Okay. Okay, so there's nothing inside with the X, so our X coordinate stays. But this -2 means we're gonna go down 2. So everybody on your graph, go down 2. Okay. Now, technically, we have a 1 in front of our absolute value, right? A is 1, which means we are going to count our slope of 1, or if we need to think of it as 1/1, to the right. Are you ready? Up 1/1, up 1/1. There is half of my V. Then we're going to do the negative slope on the left side. Up 1, left 1, up 1, left 1, to make the other half of our V. Boom, done. Okay. Why is it the shape of a V? Let's go back and talk about that. Okay. When we are putting numbers in for the absolute value, okay, the absolute value of 1 is 1. The absolute value of 2 is 2. But then when we plug these negative numbers in, those outputs are positive, right? So what's happening on the right side is going to reflect what's happening on the left side because of that. Does that help? I mean, that's where these are coming from. So would you rather me say, all right, Connor, let's plug in a bunch of random numbers. So if I plug in 0, the absolute value of 0 is 0 -2 is -2. So there's that point. And then plug in another random number. Okay, let's plug in 2. The absolute value of 2 is 2 -2 is 0. Okay, so here's that point right there. That's going to take forever, right? So what we're doing is we're taking the fact that I know that this is what it looks like, and I know how those different numbers are going to affect where this graph goes. So we're going to be able to do it faster. Do you like that? You don't like that we're doing it faster? You would rather do the slow way? So I'm confused. Okay, do you want to go slow or do you want to go fast? He's not getting what I'm asking. Okay, Maddie. No. They will have to be straight. Okay. All right, so let's go to the back side. Let's look at number 6. Number 6. Okay. Kyron, what do you think about the vertex for number 6? Okay, so how are we going to write that? comma. Okay, -2, comma 0. Harry, how did he get -2, comma 0? You don't know at all. So that's where he got the 0. Okay, how did he get the -2? No, so when it's inside the absolute value, if it's plus, we're going to the left. If it's minus, we're gonna go to the right. Because, look, x minus h. So when it's plus, that means we have a negative. Does that help? Okay, so our vertex is -2, 0. Here that is, right here, guys. All right. Hey, what does this mean right here? Maddie? Okay, it's -1. So, Cassie, you just did this. Okay, it's going to be upside down, right? So it's going to be reflected. Okay, but A is still that 1, but we're going to have to be technically a -1. So what we're going to do, we know that this is going to be upside down. So to the right, I'm going to count a -1 slope to make that half of the V. And then to the left, I'm going to count 1/1 again, but in the positive slope. And there's our graph. We don't even need an XY table. How cool is that? I don't want to hear it. Debbie Downer. All right, I like graph number 7. This one's gonna be great.
I don't know upside down.
What?
We're in math class.
So do you see this negative right here?
Yeah, but like,
So that means it's gonna flip upside down.
but can you also go like this? No.
So like the whole V has to go upside down. Like all of the Y values are going negative. Yes.
After this one, chart, a chart like that to understand like how those would work.
Okay. All right. So our vertex. Our vertex for number 7. Where is it, Ian? Comma 3, comma 2. Okay, so we're gonna go to 3, 2. All right, our A is 2/3. So is our V gonna be wider or skinnier?
Wider.
It's gonna be wider. Okay. Okay. So what we're gonna do is we're gonna count our slope to the right, up 2/3. We're gonna count our slope to the left, up 2/3 the other way. What?
These are notes.
Okay. Now, I think that it is easier to count slope, but if you don't like that, you have this option. My vertex for number 8 is at 1, 3. So if you put that in the middle of your XY chart, you could pick a couple numbers on each side of your vertex. Okay. So Maddie asked if we could just kind of talk about like what this would look like. So if I plug in a 0, what is 0 minus 1? The absolute value of it. So -4 times 1 plus 3 would give us -1. Okay. In the essence of time, the same thing would happen when we plug in 2. That's a lot of plugging and chugging. Is it as efficient as counting slope? Okay, you're gonna have to graph. Tonight. Are you jiggly on this? I'm giving you graph paper if you can't be patient.
Carter, you said you quit this. No, freshman.
So -4 times 1.
Where's my water bottle?
Yeah.
I actually